Hello and welcome to my channel. My name is Zahra and here I'll be sharing what I've been learning with you.
In advance, let's begin with this question. Why is it still important? Due to its abundance in the earth, low cost, good mechanical properties, and the ability to achieve desirable property by adjusting its composition, steel is incredibly important to us. Next question is, what is it? Steel is an alloy made of iron, carbon, and the other alloy elements. In ferrous alloys, iron forms the base, actually is matrix, and the carbon is the main component that strengthens it. But what about the role of the other elements? That's the subject of this course, and we will discuss it in future sessions. When we look at ferrous carbon diagram, we see three main transmissions that occur in steel while it is heated. The more carbon contained, the strength of steel, but also more brittle it becomes. However, there is a threshold beyond which the material is no longer steel but cast iron. Where is the threshold? When the carbon content exceeds approximately 2% and you take to it transmission. When we talk about the advantage of steel, we mentioned its good mechanical property. One of the most important properties that makes steel attractive is toughness. Toughness is, while being a strength, it also flexible, meaning it doesn't fracture in a brittle manner like cast iron and has a smooth fracture surface. In fact, whenever elongation of material is more than 5%, we can expect a ductile fracture. When we applying tensile force, it elongates, and the result make a curve that shows steel behavior. At first, we observe a completely linear behavior, meaning as we apply stress, the material elongates. Beyond this point, the linear behavior change. However, if we release the material and stop applying stress, at this point, it will return to its original shape like a spring. So, up to a certain point, the material exhibits elastic or spring-like behavior. Beyond this point, the material yields and plastic deformation begins. We call it yield. The material can undergo plastic deformation until necklace, meaning a localized thinning occurs in specimen. After this, the material break and fracture occur. During manufacturing, especially during forming process, we need to stay within the elastic range, particularly for manufacturing springs. In order to design a spring, we need to focus on the elastic region. There's a parameter in this area, which is a resilience region called Young modulus, which depends on intrinsic properties of the atomic bonds. So, how can we increase this region? By increasing its strength. How? By adding carbon. Material become more capable to form martensite phase, which increase strength by adding carbon. But the specimen become less ductile and difficult to weld. So the carbon content plays a significant role in naming steels. How? If it's a plain carbon steel, meaning it's just iron with carbon and no alloying element other than 4 elements A, B, C, D. They are magnesium, silicon, phosphor, and sulfur. They are always present in steel. So why are some of them marked red? Because the red ones bring undesirable properties and the other ones bring desirable properties. So plain carbon steel classified as low carbon, medium carbon, and high carbon steel. And I believe now you can tell me which category show more strength and or which one of them is better for welding. Imagine yourself in your office and receive the unknown steel specimen. The first step is to take the specimen to quantometry. Outcome of this test is a table full of elements with different percentages, but are all these elements play important role in order to recognize a specimen? Iron is the base. Carbon is always present. In addition to these, we always have the 4 elements we mentioned before. So what about the other ones? EN 120 table going to help us. This table tells us to only consider values above a certain threshold. So now we are able to cross the elements that are lower than critical value. So now, in addition to iron base, we can see 0.15% carbon and 4 inseparable elements, which undesirable ones are low. So we have a clear carbon steel.
Thank you so much for your attention. I hope you found this video helpful. I'd love to hear your thoughts, so please leave me a comment below and subscribe for more tutorial videos. See you next week. Bye!